Today I want to introduce you to the Electronic Tag Universal File Format, or eTUFF, that was developed as part of our NASA OIIP project. The problem that we face a lot of times dealing with tag data is every manufacturer has its own data organization and file format, and they are not standard compliant, so it makes handling these data really challenging. For example, just look at this one tag and you can see tens of files from just one single file, and you know how challenging dealing with more than one manufacturer in that setting. So our solution is eTUFF, Electronic Tag Universal File Format. We propose a normalized specification in a comma separated format, or CSV, so that it can handle any tag data type. And the way that we do it is by having a standard header line that any value from different sensors, instruments can all utilize. And briefly, it's basically date time, variable ID, variable value, variable name, and variable units. And as you can imagine, you can fit almost any type of sensor data into this setting, and we'll walk you through more in details later on. And also, eTUFF has a metadata section. It can be tag-specific metadata like deployment time, who did it, your institution, or serial number. And there's also other metadata that are standard compliance, like CF, HCDD, or NCEI metadata that can be part of that section. By including those, then eTUFF becomes a self-describing file, having both the metadata that will describe what those data are for. And if you open up eTUFF file, it looks a bit like this. So they are on the top is the metadata section, and you can see the attributes like who's the manufacturer. In this case, it's a microwave telemetry, and the tag model is an X tag. And there's also a serial number here and the platform transmitter ID. So all these metadata can be populated to describe the data section. And you can see the data section is just having different data that lives under one header line. And I'll show you now a bit on the metadata first before showing you the data itself. The metadata, the easiest way to learn about how we implemented metadata is going back to our OIIP website and look under documentation, the first document. You see a smiley face here. That's the one that will describe what we did to handle electronic tag specific metadata. And also on the same website, you can find a more detailed document that goes into what we are trying to describe here in the eTUFF. And I'm just here to show you a quick preview of what metadata looks like. You can go to this link to explore the same full list. And basically, some of the required ones are the ones that will populate the first section of an eTUFF file, like manufacturer, model, serial number that we talked about earlier in the previous slides. So that takes care of the metadata section. And then we move into the data section of an eTUFF file. And under that header line, date time is what we meant there is basically year, month, day, hour, minute, second, according to ISO 8601 standard. The time zone is assumed to be GMT because it's mostly what the tag manufacturer default setting has. It can be left empty for some timeless elements. Let's say I want to document for depth histogram what is the bin setting. So you have maybe 150 meters as the lower limit of that bin, 200 as the upper limit. So you can actually specify that, but it has no time element in it. So in those cases, you just leave it blank by having double quotes in the CSV file. So the next element is variable value, and that basically stores the sensor measurement in the data value. So just the value itself, no units, because it will be handled by something later. So it's a double precision numeric value, pretty straightforward. Then the last piece of the data section involve variable ID, variable name, and variable units, which basically describe what the variable value is about. And you can get the full listing that we have compiled from studying across the different types of tag out there to build a preliminary list that we think it would be pretty useful as a starting point. So if you download it and open it up, you can see what it's about. It has those three elements: variable ID, name, and units. And it can be, let's say, for depth, and you can see the units there we use is meters. For temperature is Celsius. So it's a pretty long listing, but it provides a starting point for us to, as a community, to work along, especially as new sensors come into availability for users to use. We can expand this list and we can still keep using the eTUFF format. So hopefully we'll enlist more support from the community to help develop this master list. Lastly, I want to show you just some examples of implementing the eTUFF data section. So the first example is a time series measurement, only for depth. And you can see time progressing here in every minute, and the variable ID is number 5, and what variable ID number 5 is basically depth in meters, and that's the value itself. So pretty straightforward. You can build temperature or light, whatever and whatever later on as well. The second example is histograms. So as I mentioned, you can have histogram data in the same format, and the first thing that you must do is to specify what histogram bin that we're talking. So in this example, we're only looking at bin number 8, and it's actually a depth bin, and there's a min and max value for that bin. So it's basically from 150 meters to 200 meters, and you can see there's no date time element. It will just be fine. And then the data itself here is time spent at that bin at that particular summary period, which in this case was 6 hours. And you can see here basically saying 20% of the time at that 6-hour interval is spent at that bin 8. So that maps back to 150 meters, 200 meters. So you can keep building it up for other bins that you have. And as you see, again, it fits nicely into this headline. And lastly, there's a profile-like type of data, which basically the tag will pick some standard depths or a certain interval, depending on how it was programmed. And then at that depth interval, what would be the value for some measurements. So in this case, let's look at a depth measurement number 4, and at that depth measurement, you summarize the maximum and minimum temperature at that depth. So you can see this free row from the same timestamp document at 104 meters. The minimum temperature is 18.45 and the maximum temperature is 18.7. So this way allows you to also handle profile-like data. So in summary, eTUFF eliminates the complexity of the current highly variable eTag data format across different manufacturers. It also provides a way to grow in the future because, as you can see, we can flexibly add new measurements to the variable types, and it does ensure interoperable file production via machine tools such as Rosetta, which is another component in our project, and you can check this link out to see how we do that. So that's all for the eTUFF. I hope you find this useful.